He is the lecture of a renowned mathematician who is not renowned in India only, in abroad also. He is a renowned number theorist. Number theory is a part of mathematics. We now welcome Professor Sukumar Adhikari, who is a renowned number theorist and presently Dean School of Mathematical Sciences in the Ramakrishna Mission Vivekananda Educational and Research Institute, Belur Math. He is a fellow of the National Academy of Sciences, India. Sir was formerly professor in Princeton Research Institute, Allahabad. His mathematical interests include mainly number theory and combinatorics. He has published many research articles in highly reputed journals of mathematics. Sir is a member of National Board of Higher Mathematics and was a president of Indian Mathematical Society, and he has authored many textbooks of mathematics. Before starting the lecture of Professor Adhikari, I request Dr. Sumana Pal to felicitate Sir with a flower bouquet and a memento. Sir, please.
Hey, sorry, sir.
Now I request Sir to start his lecture, and Sir has already told he will be interacting with you and you are free to ask him any question. Thank you.
एक कॉलर माइक्रोफोन টা লাগবে কলার মাইক্রোফোন এই যে এখানে
এখানে না কোথায় এই নদীতে Okay, is it audio now? So let me first thank the department of Aliah University and especially for organizing such another program. So welcome. So now I know that many of you have not heard about number theory. So I'll start from the beginning. You can stop me anytime, whenever you have any difficulty. So, I'll assume few things because you cannot go too much behind, then you cannot complete anything. So, integers, you know, this is integers. Okay? Are you listening? So this is the notation I put is Z. Okay? This comes from German language, so it's Aliah. So then there are these 0, 1, 2 onwards. This is the notation is natural numbers. Okay, are you? And 1, 2 is positive. Okay? So these are the some notations. Then there is division algorithm. Okay, you can prove by induction. some basics, I mean, I will not go to. So here also some two axioms I will say, mathematical induction. I will not go to construct integers from pure axiom and all, then we will be in the labyrinth of many logical things. So mathematical. Yes, 1 minute. Any question? See, depends if there are many books. All books different. So what I define for my lecture, you can measure. So there are no, see this, even N, some people write this, some people write this. So what I will be using, that is natural. You in your pocket, you put in your pocket, hand, no money. How much money you have? 0. So that is natural. Negative, that's why it was not there before. So in some books they put 0 as natural and they put N. So the books vary, so it is easy to know. Because once one very small child asked me that what are the books where from you can get the truth. Because they know that all books and newspapers, all things may not be correct. Now what is the source from where without, I don't know, there is no clear-cut answer. You have to talk to people and this and later on. See, similar and notations and all, they differ, book to book. So what I am using is, this is the set of integers and this is a group also, the ring also, but I will not use much algebra because, and this is natural number and this is positive integers. This is notice. Okay? Yeah, you can ask about it. So now, mathematical induction, what is this? That if you put, suppose, true or 1. Suppose for n equal to 1, if it is true, and true for m implies true for n plus 1. Then it is true for all. All. Then true for all n belonging to all positive integers, it is true. If it is true for 1, and then if you prove that if it is true for m, then it is true for n plus 1 and so on, then it is true for, you don't have to prove. How do you prove something for? See, one my teacher, Professor Ramchandra in Adhikari, he was very famous. Somebody asked, is number theory is about 1, 2, 3, 4? No, it is 4, 5, dot, dot, dot. So that dot, 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 when you say that something is true for all integers, okay? Like that when you say that all positive integer is a sum of 4 squares. That is, question is not to prove for 1. 1 is 1 plus 0 plus 0 plus 0. 2 is 1 plus 1 plus 0 plus 0. 3 is 1 plus 1 plus 1 plus 0. Like that you can go on. But that way proving for some will not, you have to prove for all. So you see that, so these are interesting results. Okay? So this is mathematical induction. Once you go by any pure axiom, so there are many axiomatic things and one may not agree with another and there are other things. I will not take you to all this. So this is for induction. And then there is, if A is a subset of set of positive integers and A is, this is a notation, this is empty set. A is not equal to empty, that means A has some element. Then it has a minimal element. Implies A has a smallest. So these two I will assume. Okay. and I don't go before that. With this you can manage, but you have to start from something, because all thing is axiomatic, you know. And in axiomatic there is a problem also, that in any axiomatic thing, there is something which you can neither prove nor disprove. You see? So, but here we have to see what we can prove in this axiomatic system. So these are two. This is principle of mathematical induction, and this is, it has a smallest element. I didn't go through all the cases. So this is now division algorithm. If you have A, B, these are integers, and A is positive, implies there exists Q R belongs to Z such that this V is equal to QA plus R, where 0 less than equal to R less than. This is division algorithm. So this is, you are dividing. By the way, all these students, school students, you know Bengali, or some of you don't know Bengali? All Bengali. Anybody doesn't know Bengali, raise hand. So I can sometimes change language and tell you if you have difficulty. So all are Bengalis, no? No, sometimes I will tell. Okay. So this what you say, that the bhag kora hচ্ছে স্কুলে তোমরা শিখেছো, okay? So this is your dividing, okay, by A. So this is Q into A, and it is bhag শেষ remainder, okay? So you will say this is quotient, this is remainder. Now what is happening, this remainder, can anybody tell this how many possibilities of the remainder? Somebody raise hand. How many? I have written already. Anybody? You are asking this. What are the, I have given the possibilities. How many possibilities? 0 to A minus 1. So 0 to A minus 1 কতগুলো হলো? 0 থেকে A minus 1 কতগুলো নাম্বার হলো? A সংখ্যা। There are A possibilities. Okay. So now I'll come back to this later. Okay. But I go back here to tell something. Then now define this prime, an integer p greater than 1. So this I am assuming somewhere, because I am simplifying algebra only in the integer level. So I will not use. So because this is one unit, okay, I am throwing it out. When you read ring theory, so this p greater than 1, and that only, okay, this, and if r equal to 0, we say that A divides B, and we write this A, this means A divides A. Okay? Now an integer p greater than equal to 1, such that only divisors, I mean positive, I am taking positive divisors only. Positive divisors of p are 1 and p, then these হ্যাঁ হ্যাঁ যদি ভাগশেষ 0 হয় তাহলে কি বলে?
ওটা না স্যার, আমি লাস্ট টাইমের কথা বলছি, যেখানে আছে a divides b, তো we should write b by a that.
No. That is the notation. See, this is and we write. I am not telling anything. And we write a divided like a bar b. Okay, this is the way of writing. You may not know, so. Okay, now you know prime. Now proof. There are this is theorem. So let us see one. There are many proofs. Like simple proof that okay. Now you tell me one prime. Definition did you follow? Who followed definition? See, one positive integer is only divisors are itself and 1. If you take 6, then 2 divides, 3 divides. So this is very close, I think. No. I will just. I want big below. No, before regular now it is okay. So you see, you could take 6, 2 divides, 3 divides, 2 is not 1, 2 is not 6. So 6 is not a prime, but 5 is. So you see, but 1 I am not, for 1 also it is true, only 1 and 1 divides, but there is a thing, because this is unique. It has an inverse, so I don't go to that. We decide not to call it prime. Okay? There is a reason soon. Because 1 can be written as 1 square, can be written as 1 cube. We don't want ambiguity. We want uniqueness in factorization, so 1 is not a prime. So now, how to prove that there are infinitely many primes? So there is this proof. Okay, this is Euclid's proof. Now you see before that, suppose any problem on reflection, is it? Some reflection.
Yes.
Now it is okay. So between, suppose you take multiple of 5, then this is 0, 5, 10, 15. So between two multiples of, and this is, we say that A divides B, so A is a divisor of B and B is a multiple of A. That's also you say, divisor and multiple. Now, these are the multiples of 5. 0 into 5, 1 into 5, 2 into 5, 3 into 5. So between two multiples of 5, the difference is multiple of 5. Because this difference is 5, this difference is 10. So two consecutive things, like that suppose 5 and 6 cannot be multiple of 5. This is follow. So for any prime, the minimum between two, the minimum distance between two distinct multiples of 2 is 2. So two consecutive things cannot be divisible by the same prime. This will follow. Now what is this? Suppose the proof. This is absurd because you see that assume, then you get into some problem. Then you say, we are a teacher in college. He used to say that, say this wall is not there. Suppose there is a wall. Then you say, oh, there is no wall. When you go, you break your nose, so there is a wall. So that's all he used to tell. So going back to that, So let us assume, suppose there are 100 many primes. Suppose the only primes are, one is P1, P1 you know this is 2, P2, 3, then like that up to PR. Suppose at some point you go and only R prime you find, and there is, assume there is no more prime. Then consider this, now there is, before this of course, because I am not using this arrangement, so I have to tell one theorem. This theorem I will not prove. You assume that by induction it can be proved. What is that? Every integer can be, every integer n can be written as n into n equal to epsilon into P1, R1, PT, RT, where epsilon is equal to 1 or minus 1 and PI's are primes and RI's are positive integers. So every integer can be written as a factor of prime. If you say minus 6, suppose n is minus 6, then minus into 2 into 3. Minus 12 is minus 1 into 2 square into 3. Like that. So it is a product of distinct primes. You can write distinct primes. And also which I am not writing, this is unique up to rearrangement. Unique up to rearrangement meaning your 12 you can write as 3 into 2 into 2 or 2 into 3 into 2. If you want distinct, then you can write 2 square into 3 or 3 into 2 square. You can calculate. Okay. So up to that, so now take this number n equal to P1 into P2 into PR plus 1. Okay. Then this also, because the n will be a product of primes, so n is equal to, or this I could have written that this into, I forget these RIs, I can write single, but then I say that this uniqueness will not be distinct. Then distinct I can write. Okay. I can take 2 into 2 into 3, 3 into 2 into, but this was the same thing. So this integer can be written as a product of primes. Q1, I can follow that one, Q1, Q1, QL, PL. Okay? So these are distinct primes, and this maybe these are not distinct. So where QIs are distinct primes and PIs are greater than equal to. But I use this result to show this. So that means what? This means this is divisible by Q1. This is a Q1 is there, so this is divisible by Q1. So that means this is divisible by Q1. Okay? But if this is divisible by Q1, then Q1 cannot be equal to P1. Because P1 divides this. Same integer cannot divide this integer plus 1. Two consecutive integers, this integer and this integer are consecutive. Consecutive follow next to each other, like 5 and 6. 5 and 6 cannot be divisible by the same time. 6 is divisible by 2, but 5 is not divisible by 2. 7 is also, 6 and 7 are consecutive. 2 divides 6, but 2 doesn't divide 7. 3 divides 6, but 3 doesn't divide 7. So if something divides some integer, if you have, that cannot divide that plus 1. So this P1 cannot divide this. P2 cannot divide this. PR cannot divide this. So that means what? So Q1 is not equal to Pi for I is equal to 1 plus 1. So a Q1 a কোনো Q1 এর সঙ্গে সমান নয়। But Q1 is a prime. So what is this? We thought that these are the only primes, but we got another prime which is not any of these. So that shows that there are infinite many primes. Okay? Alright? Now, this is over. Everybody followed? See, even very simple things you follow, then you can follow the higher difficult things. Okay? Any problem? Did you follow? Hello? You? No, that. Did you follow or not? You are listening or not?
স্যার আমাদের মাঝে মাঝে একটু ল্যাঙ্গুয়েজ প্রবলেম
স্যার মানে ওরা তো ব্যাকগ্রাউন্ড থেকে বেশি ভালো
স্যার অনেক কিছুই
No, I asked them that if they need Bengali, they are Bengali, no?
তোমাদেরকে বাংলায় হলে ভালো হয়
আরে মাঝে মাঝে বাংলায় বলে দেবো আমি but you could ask me the question, no? This terminology there is Bengali you cannot go because there are no it is not that he is finding difficulty, he is talking to somebody and laughing, so that way you cannot that way you are disturbing yourself or others.
স্যার ইটস ওকে উইথ মোস্ট অফ
No, sometimes that will be. Okay. No. No. Hey, in front of your white shirt. Okay. Now, that is okay. Then let us come back. So we understood that there are infinitely many primes. Okay, 2, 3, 5, 7, like that you go on, and you can always continue finding primes. The gap between primes and all, they are very difficult subjects. Now you are even research going on now, so now I will tell you that prime, when you write this, suppose 4n plus 0, 4n plus 1, 4n plus 2, 4n plus 3. If you divide an integer by 4, if you listen, what is your problem? যদি 4 দিয়ে ভাগ করো কোনো একটা ইন্টিজারকে, ওকে, your number q, এই যে লিখেছি q, your a is b, so write b. So b is equal to 4 into that q is n, okay, and so 4n plus 0, r is 0, and what are the possibilities? When you are dividing by 4, 0, 1, 2, residue can be 0, 1, 2 or 3. তাহলে ভাগশেষ কি হতে পারে? 4 দিয়ে ভাগ করলে 0, 1, 2 আর 3। ওকে, এখন প্রাইম হতে গেলে এইটা কি প্রাইম হতে পারে এরকম নাম্বার? হতে পারে না, কারণ এই যে 2 বের করে নাও, তাহলে 2 into 2n plus 1, তাহলে এই ধরনের জিনিসগুলো প্রাইম হতে পারে না। এই ধরনের জিনিস প্রাইম হতে পারে কখন? যদি প্রাইম হতে পারে না, এইটা হতে পারে কখন? যখন n equal to 0। See, there is, I made a mistake. This can never become. And this can become only when n is equal to 0. So this is only 2. If n is equal to 1, it cannot happen because 2n plus 1. When 2 into 0 plus 1, then there is 1. So this is only one prime. But this and this, we will see that there are infinitely many primes in both of these things. Okay? Let us prove that. So how do you prove that there are infinitely many primes of the form 4n plus 2? So, there are infinitely many primes of the form 4n plus 2. 4n plus 1 will take bit more time. Okay? So, you have to prove that there are this 4n plus 0 there is no prime. 4 into n can never be prime. This can be a prime only when n equal to 0. Only 1. After that it is not because you take 2 out, then 2n plus 1. And then this and this, you will see that there are infinitely many times in both of them. So first of all, this, can anybody try? Because for that one observation is needed. What is the observation? Like here, to prove that earlier result that there are infinitely many primes, we observe that distance between two consecutive primes cannot be 1. Consecutive multiples of a prime cannot be. একটা প্রাইম দিয়ে বিভাজ্য দুটো সংখ্যা পরপর হতে পারে না, মানে দুই যদি কাউকে ভাগ করে তার পরের সংখ্যাটা দুই দিয়ে বিভাজ্য হবে না, তার গ্যাপটা বুঝতে পেরেছ? সো হিয়ার উই ডু অ্যানাদার থিং. Okay, so what do we do? That suppose the age, because see, if multiple of 2 means it is even number, and if you take an odd number, take an odd number, n odd. Now n odd will be product of primes. Let us forget the power. Okay, if at all you can repeat P1, P1, P1 like that. So P1, P2, P3. Suppose n is a product of primes. Now these primes can be of what type? 4n plus something, 4n plus something. So prime होते हुए क्या होता है? हाई 4n plus 1 होते हुए, नहीं 4n plus 3 होते हुए. So this is 4n plus 1 or 4n plus 3. Any pi, either this or this. Okay? Do you follow? লজিকটা বুঝতে পারছো কি বুঝতে পারছো না? যখন n কে প্রোডাক্ট অফ প্রাইম লেখা গেল, এখন যদি n টা অড হয় তাহলে 2 থাকবে না। তাহলে 2 যদি না থাকে অন্য প্রাইম গুলো কি রকম হবে? 4n plus 1 নাহলে 4n plus 3। এখানে যদি দুটো ইংলিশ আর ম্যাথমেটিক্সের ছাত্ররা কোথাও পড়াতে যায়, ওখানে কারা আছে? হয় ইংলিশ নাহলে ম্যাথমেটিক্স। তেমনি এখানে এরা কারা? হয় এই টাইপের নাহলে। ঠিক আছে, এখন সবাই যদি এই হয়ে পড়ে তাদের প্রোডাক্ট কি হবে? দেখো তো 4n plus 1 আর 4n plus 1 গুণ করে দেখো তো, এটা 4 সামথিং প্লাস কত হয়? এটাকে যদি 4t plus 1 লিখতে হয় তাহলে কত হবে? See, every integer কে আমরা ভাগ করছি 4 ভাগে। কিরকম? 4n plus 0, 4n plus 1, 4n plus, তারপরে ওকে ওর একটা নাম আমরা দেবো রেসিডিউ ক্লাস কত হ্যাঁ
Sir, 16 M.
whatever now you take 4 into something plus what is the remainder
1.
1. So if you take multiple of 2 1 mod 4 এগুলো বলা হয় 1 mod 4 I'll come to that তাদের প্রোডাক্ট 1 mod 4 তাহলে আরেকটা যদি নাও তাহলে তাদেরও প্রোডাক্ট 1 mod 4 তাহলে এরা যদি সবই 1 mod 4 হতো এদের প্রোডাক্ট 1 mod 4 হতো if you take all several integers each is 1 mod 4 their product is 1 mod 4 so one should let if possible let the only prime of the form 4n plus 3 be 3 আমরা চোখের সামনে দেখতে পাচ্ছি 3 আমরা চোখের সামনে দেখতে পাচ্ছি 7 and আমরা জানি না p k up to this we have got okay now what you have to consider n is equal to this 4 into 7 into whatever into pk এই ইন্টিজারকে কনসিডার করা is an integer it will be divisible by some time it is a product of time so if p divides n then no there exists p divided n such that আচ্ছা এর সমস্ত ডিভাইজার গুলো যদি 1 mod 4 হয়ে যেত হতে পারে না এর সব প্রাইম ডিভাইজার গুলো যদি 1 mod 4 হতো তাহলে এটা 1 mod 4 হতো এখানে আমরা দেখলাম সো তাহলে এর একটা অন্তত 3 mod 4 ডিভাইজার আছে বুঝতে পেরেছো দুটো 3 mod 4 এর মাল্টিপল 1 mod 4 তিনটে 3 mod 4 এর মাল্টিপল 3 mod 4 আবার চারটে হলে আবার 1 mod 4 তাহলে এর সমস্ত প্রাইম ডিভাইজার গুলো 1 mod 4 হতে পারে না that means there exists one prime such that p is congruent to p mod 4 তাহলে একটা 3 mod 4 প্রাইম আছে ডিভাইড করে সেটা কি 3 হতে পারে না if that is 3 then n is divisible by that and 3 is divisible by that so that minus 3 so this is divisible by that can হতে পারে কারণ this is not divisible এখানে কোনো 3 সেটা কি any of these এগুলো হতে পারে না কারণ you take n minus 3 that is divisible by that and that is this is divisible by that then 3 will be divisible by that cannot happen if you don't follow I will explain to you again so p not equal to 3 7 pk কারণ এটা যদি হয় 3 হয়ে যায় then it will force that 3 divides এবং এই যদি কোনো এইগুলো কোনটা হয়ে যায় that will force that 3 is divisible by that cannot happen so p is not equal to that then you take so we got a prime which is 3 mod 4 and not equal to any of the old ones so you have a new but you cannot so far we have not proved that you have is 1 mod 4 also there is made. For that you have to go. What is the time limit? 1 o'clock. So I will go slowly, and then we will see congruence, and then we try.
স্যার
হ্যাঁ
একজন বলছে লাস্ট আপনি যেটা বললেন আরেকবার একটু রিপিট করুন
হ্যাঁ that is actually tricky good that you are asking is simple but you have to think to see that the a is equal to b plus c half okay and suppose some p divides a and p divides c can you tell that P divides B?
A divides
ওটাই কারণ P A কে ডিভাইড করে C কে ডিভাইড করে তাহলে implies P divides A minus B বড় তো তাহলে P divides sorry P divides A minus C so that P divides A, P divides C implies P divides A minus C. A minus C equal to B. You follow? Similarly, here, if P already divides N, if P is equal to 3, then P will divide N minus 3. So P has to divide this. Do you follow? So that means if P is 3, then 3 will divide N and 3 will divide 3. So 3 will divide N minus 3, and 3 will divide this. But that 3, where will it divide? These are distinct, no? So this is not possible. Suppose your P is 7 or something, whatever next, okay, you calculate next 3 mod 4 prime, 13 or whatever, no, not 13. You calculate. So if it is one of these, then that divides N and that divides this, so that divides N minus this. So that means that divides 3. So, but A prime will be equal to 3 divide 2. তাহলে এটা নতুন প্রাইম এই যে there exists a P divided N যেটা 3.4 সেটা এদের কারণ নয় সেটা 3 ও নয় 7 ও নয় তারপরটাও নয় তৃতীয় নয় যারা নতুন
মানে স্যার আমাদের অ্যাসাম্পশনটা ভুল ছিল প্রথমে
না এটা ভুল ছিল যে this is wrong then the only prime up to this that is wrong so we got a new so there are infinite
মানে স্যার 4n + 3 টাই একমাত্র ফর্ম অফ প্রাইম নাম্বারস নয় এটাই আমাদের কনক্লুশন আছে কোন
না কনক্লুশন হলো যে 4n + 3 টাইপের ইনফাইনাইট মেনি প্রাইম আছে 3 আছে 7 আছে তারপরে ইউ গো অন ডুইং হ্যাঁ তার দুগুণে 8 আর 3 11 then you go on doing okay you go on doing তার 3 12 একে 12 আর 3 15 নয় then you have to go next one but there will be infinite this way you cannot prove but we have proved that there are infinite because this
স্যার ডিভাইজারে 4 কে কেন নিয়েছিলাম অন্য কোনো নাম্বার দিয়ে যদি প্রোগ্রাম করি
হ্যাঁ
ডিভাইজারে স্যার 4n মানে ফর্মটাকে 4n প্লাস সামথিং কেন করে স্যার অন্য কোনো যদি করতাম
অন্য করতে পারতাম but there is a theory this you can do simply because 4n type only two type 4n plus 1 and 4n plus 2 আর অন্য হলে আরো হবে যদি আইল কাম যদি মনে করো 8 কর তাহলে 8n plus 1 টাইপের হবে 8n plus 2 হতে পারে না plus 3 হবে 8n plus 4 হতে 5 হতে পারে plus 8n 6 হতে পারে না এরকম হতে পারে বুঝতে পেরেছো কিন্তু যদি তোমার ইয়ে হয় ওই 4 হয় তাহলে আমাদের দুটো ক্লাস কতগুলো ক্লাস থাকবে যেগুলো কো প্রাইম টু 8 ওকে সেটা আলাদা that there are infinite many for any AB A or B co prime that is the theorem in analytic number theory that you cannot prove elementary
থ্যাংক ইউ স্যার
স্যার বলছি 6 এর ক্ষেত্রেও তো দুটো পসিবিলিটি হবে তাহলে আপনি ওটা কেন ধরলেন না
easy now 6 seconds see you have to again work it is see for general it is not very easy you understand 6 seconds কি হবে 1
6 plus 1 হবে 6n plus 5 হবে
I got it 2 3 4 হবে না so that's all that is also true that part that is a theorem here you can easily argue and there you will not show the equal you can try and somewhere you will be successful somewhere you will not but there is general analytic number theorem I'll come to that first let us understand this okay we are going very slow even now So, did you follow this one? You followed now. So that means there are 4n plus 2 type are only 1 prime, that is 2. 4n plus 0, there cannot be any prime. And 4n plus 3, earlier we took, they are infinitely many prime. And 4n plus 1, we have to prove. We have not proved it. Okay? So, we have not still proved 4n plus 1. You see, have to prove and then you will know that you can try at home 6 and একটু ধরে ওকে Okay, so now what I am defining, okay, this is a Gauss symbol. So if A is congruent to B mod Q, this is same as Q divides, okay. This is symbol. Okay. Now you can, these results I am not proving, you check it at home. That this one A is congruent to B mod Q implies. In fact, I could have defined, I am not telling equivalence relation because reflexive, symmetric and is okay. Reflexive, symmetric and transitive. Okay? But I don't want to do that, I go easy way. This A congruent to B hard, then B congruent to A. Because if Q divides A minus B, then Q divides B minus A also. And 2, A is congruent to A mod. This is reflexive. Because A minus A is 0, 0 is divisible by any. And 3, A is congruent to B mod Q and B is congruent to C mod Q implies A is congruent to C mod Q. So this is a transitive. So this next word, they make a group. They make a group of elements that class. Okay, these are called equivalence class. So the whole integers are divisible into how many parts? That divides that if A is equal to 0 থাকে 0 mod Q হয় 1 mod Q হয় তাহলে কি 0 mod 1 mod 2 mod. Now this is what I am trying to tell you bit quickly also and avoiding many abstract things. So what is this? যদি দুটো সংখ্যা Q দিয়ে ভাগ করে যদি ভাগশেষ 1 হয় তাহলে তাদের ডিফারেন্স ইজ ডিভিজিবল বাই, do you follow? That যদি something let us take Q is equal to 7. Now 7 into something T plus 1 and 7 into T1, 7 into T2 plus 1. If you take this, their difference is divisible by 7. Do you follow? that if যদি ডিভাইড রেসিডিউটা এক হয় কিন্তু রেসিডিউ যদি আলাদা হয় 7 into T1 plus 2, this and this their difference is not divisible by T1, by 7. You follow? So similarly, if two integers are in this group, means the remainder is 0 after dividing by q, then they are equivalent mod q. You follow? Similarly, if two integers, their remainder is 1 after dividing by q, then they are in the same equivalence class. Then this. So how many class? Other remainder 0, other remainder 1, other remainder 2, and other remainder 3. And এখানে যারা থাকবে, যেমন you take for q equal to 7, then 7, 14, 21, 28, these are one equivalence class. Day-to-day activity, your days, like that, if this is Sunday, then after 7, if after 7 days, what it will be? Sunday. Then again Sunday. So this is called Sunday. If your Q is 7, then this is Sunday. This is Monday. This is Tuesday. And between any two Mondays, the number of days is multiple of 7. Either 7 days or 14 days. So this is day to day. You can see that. Okay. So this is mod q thing you get, and these are called equivalence class. Okay. And these are called residue class in this case. Okay. So far, little bit I told about that. I will not go much in that. But what is this? This follows some algebra. What algebra? That if that A is congruent to alpha mod n and B is congruent to beta mod n, then what happens? 1 ax plus by is congruent to alpha x plus beta y. For all integer x and y, this is true, because you can check that, because they are different. A minus alpha is divisible by n, b minus beta is divisible by n. So this minus this is divisible by n. You take it and bracket. Okay, it will be, you will follow. The next you take common, a minus alpha is divisible. Take y common, b minus beta is divisible by n. So the whole thing is this minus this is divisible by n. So 2 is that AB is congruent to alpha beta. Product is also mod n. And then 3 is the power. Alpha to the power n. Take the same thing, is congruent to a to the power n. So if that is the thing, this is also true. You would take an integer coefficient a to the power xn, then a naught. You put alpha here, alpha, a n minus 1 after 0 minus 1. This is congruent to n a to the power n plus a n minus 1. That means in this polynomial, if you put this and this, then there. If alpha and a are equivalent mod n, then this polynomial and this in the polynomial a n x to the power n etc. If you put alpha or a, they are congruent mod n. So you see that 10 examples, 10 is congruent to 1. Is it true or not? I don't know, some of you may know. Take this integer 1, 1, 1. No bar लिखी 9 times. 3 बार लिखले बताओ 111 তারপরে 1111 লিখতে পারো। এটা 9 বার লেখা আছে 111। এইটাকে যদি কেউ তোমাকে জিজ্ঞেস করে 9 দিয়ে ভাগ করা যায় কি? হ্যাঁ, যায়। কেন যায়? তার প্রুফ। তারপর 10 is congruent to 1 more time. ওকে, এন্ড তুমি যদি লেখো একটা নাম্বার যার ডিজিট গুলো যদি 5 7 3 4, this is what? This is 5 into 10 cube plus 7 into 10 square plus 3 into 10 plus 4. ঠিক আছে? This is congruent to, because 10 is congruent to 1, so এটাকে 1 দিয়ে replace করতে পারো। This is congruent to 5 plus 7 plus 3 plus 4 more 9. So এটাকে তুমি যোগ করে দেখো, 5 7 12, 13 15, 16 17 19. So 19 is not congruent, not divisible by not 0 more 9. It is 0 more 9 also, then it is divisible. এখানে কি হবে? এটা করলে সব জায়গায় 1 1 1 আছে, তাহলে 1 into 10 to the power 8 whatever, then 1 into 12 plus 1 into 10 10 plus 1. So সবগুলো তোমার 1 বেরিয়ে এলো, তাহলে 1 plus 1 plus 1 9 is divisible. আর যদি 10 ভাগ থাকে হবে না, 18 ভাগ থাকে হবে না। So you know this is divisibility criteria by 9. I will learn by that. I am going a bit quick. If it is slow, it would have been better. Anyway. Now, there is something that Aliah Prof had. I will try to take up to, no, I will do that. What is that? Yeah, give it. Take one. It is only up. I think with this I will manage. I will finish this. वो जो स्प्रे आते हैं, put that. Hey, बोटे बोटे दे दे, बोटे बोटे. हाँ, बोटे दे ये बात बोल. Okay. So now, that GCD is like that when you write something, what is the greatest common divisor, that you know I will not define. And A, the greatest common divisor, is denoted by this. Now tell me some people, 2 square plus 3 plus 5 and 2 into 5 into 7. What is the GCD of these two? Somebody said, some students will get. You go to a prime, this, the minimum power which divides is 2, 3 is not here, 7 is not here, but 5 is there, so this GCD is, you follow? Take, for every prime, what is the maximum power divides both? That product you take, that is your GCD. I will not go much into that. One can prove that it is will be some x plus by time and time. Now that this is GCD, and if GCD is 1, then they are called co-prime. Like two distinct primes, 5 and 7 are co-prime. But 5 and 4 are also co-prime. Because there is no prime divides both 5 and 7. What is the GCD between 5 and 7? What is the GCD of 5 and 7? Gosagu, Bangla bole. তোমরা বেঙ্গল মিডিয়াম পড়ো না ইংলিশ মিডিয়াম? 5 and 4. Gosagu. 1. And 4 and 8? 2. 4 and 8? 4. The maximum thing which divides me. The maximum integer which divides me. That is GCD. And if that GCD is 1, then they are called co-prime. Co-prime. Mutually co-prime. Now, that take an integer n and then phi n, this is Euler constant. Okay, this is the number of integers in 1, 2 up to n minus 1, which are co-prime to n. You follow? Now you should tell me what is phi of n. You will calculate if you follow this definition. Number of integers from 1, 2, 3. So you have to see 1, 2 up to 9. How many are co-prime to n? Huh? Co-prime. Oh, acha. 1, 2, 3, 4, 8. What is the GCD of 1 and 10? 1. So there is co-prime. What is the GCD between 2 and 10? 2. So not co-prime. 3 and 10? 1. So co-prime. So how many co-prime?
কতগুলি কোপ্রাইম আছে?
হ্যাঁ
1 and 3, 2 and 3, 2 and 5,
হ্যাঁ
2 and 5.
25 হবে না 2 ও হবে না যেগুলো 2 দিয়ে ডিভিজিবল নয় যেগুলো 5 দিয়ে ডিভিজিবল see this is very easy it is multiplicative function up to it is I will tell you up to 5 how many co-prime are to 5 because 5 is a prime so we just studied that only divisors are 1 and 4 and 1 is phi of 5 is 4 any prime has 5 that p minus 1 do you follow and phi of this anything like 4 phi of 4 is 1 this you cannot say like that but all the multiple of 2 you remove so 1 and 3 so this is 2 phi of 2 is 1 and phi of 10 is nothing but phi of 5 into phi of 2 this is multiplicative if these two are co-prime then this is multiplicative phi of 10 into 5 into 5 but this is 4 into 1 you can check that phi 10 is 4 1 then 2 হলো না 3 4 হলো না 5 হলো না 6 হলো না 7 8 হলো না 9 তাহলে 5 10 is 4 now what is this now what is this you take some phi n so if you take n then they are congruent classes so there will be a1 a2 a phi n so this is less than n so these many co-prime classes are there residue classes Mark says you understand that so that will be co-prime okay so for 10 what you will get that for 10 it is you have seen 1 3 7 9 these are all the so this is a1 this is this so these are less than 10 so this you Now what is this I am telling? That if you multiply this by one of this, multiply this by one of these, 3, multiply by 3 and read what then. Can you do that? Multiply this, multiply by 3, so this is 3, this is 3 is 9, 3 into 7 is 21, 21 is mod 10 what? Mod 10 এটা কত হয়? ছোট সবচেয়ে ছোট ভাগশেষ কত হয়? 10 দিয়ে ভাগ করলে 1 আর এটাকে আমরা 27 কে mod 10 7 you see এইগুলো আবার ঘুরে ঘুরে আসছে see it was 1379 now we got 3917 এইগুলো কেন না because that will be also co-prime if multiply by one co-prime this multiply by a1 or multiply by a2 that will be again co-prime and by dividing by that n it will go to co-prime class so what happens the co-prime things get permutated okay so if this is the this co-prime these residues okay and then multiply by some multiply by some a as that a in co-prime তাহলে কি হবে তাহলে a1 a এইগুলো কি হবে জাস্ট দেখলাম এটা পারমুটেটেড হয়ে গেছে তাহলে কি হবে প্রোডাক্টটা যে গুণ করে দেওয়া যায় তাহলে এটাও এতগুলো এ থাকবে আবার a1 প্রোডাক্টটাও ঘুরিয়ে নেওয়া যায় আইএন কিন্তু মড ফলো তাহলে এইগুলোই this but then you take a common then that will what will happen that you can cancel that right. So what is happening that a to the power pn is congruent to 1 because if you take a and b minus c equal to 0 and a n যদি gcb 1 হয় then that implies n divides b minus c implies b is congruent to c so এখানে a to the power pi n minus 1 a to the pi n minus 1 so you understand so because এইগুলো just mod n they are nothing but this only সেটাই হয়েছিল এগুলো কি এগুলো 3 into a1 3 into a2 3 into a2 they nothing but them so your this is nothing but a1 a2 a mod n take common okay then they get cancelled because they don't divide so now what is for a prime p I will give some examples it will be clear so 5 is what 4 what is that difference 5 is 4 5 1 2 3 now what is that you take this any integer from 2 to the power 4 is congruent to what not 5 I know this will be 1 that's now I prove দেখো করে দেখো 2 দুগুণে 4 4 দুগুণে 8 8 দুগুণে 16 what 5 is what so this is true in any integer a p minus 1 is congruent to 1 okay
minus 1
in fact there is some literal this thing that is prime only thing which does that If you can write this like also, A is going P is congruent to A. এই প্রাইম ছাড়া এমন কোন ইন্টিজার আছে কি যারা এইরকম যে কোনো ইন্টিজারের জন্য এটা হয়? There are some called Carmichael numbers, and there are integers like 561, 3 into 17 into 11, and there was a conjecture whether there are infinitely many Carmichael numbers, and that was proved in 94. There is an announced paper by Alfred Gamble and Sukumar. There are infinitely many these sort of numbers. Otherwise, if there are finitely many, you can keep them aside, and that you can use that as a primary testing, which is needed in cryptography. But that unfortunately you cannot use this criteria because there are these funny guys which pretend to be prime in this respect. Okay? Now I don't know whether I have put cross time is it? I don't know. There are big note, but I thought I could prove that. Can I take 5 minutes? Okay. So one is that I went a bit quickly because some of this, I have some notes, I can send it part of it. So, suppose P is, I will not write now odd prime. And if there exists n such that, okay, that n square plus 1, that P divides n square plus 1, then P is equal to 4. তারপরে কি যদি কোনো প্রাইম এই ধরনের ইন্টিজারকে ভাগ করে, okay, see that cannot be 2 because this is no, P is odd prime, so that cannot be 2. That is odd prime means 4n plus 3 times or 4n plus 1 time. So, but then I am telling that this cannot be 4n plus 3 times. It has to be 4n plus 1 time. How to prove that? Because suppose, if possible, no, let us do directly. So, P divides n square plus 1 implies Pn equal to 1. জানি তো যে P যদি n কে n স্কয়ার কে ডিভাইড করে P তার নেক্সট কে ডিভাইড করতে পারে না, তাহলে ঠিক আছে, তাহলে P এইটা ডিভাইড করে তাহলে n কে পারে না, তাহলে Pn equal to 1. তাহলে we got n into P minus 1 is congruent to minus 1 mod P. Just now what I mean লিখলাম, যদি এটা কোপ্রাইম হয় তাহলে now if যদি n square congruent to minus 1 mod P, P divides this, এইটাকে মানেই হচ্ছে যে P, this is 0 mod P, এই 1টাকে এই ডান দিকে নিয়ে গেলাম। Now, if possible, let P is equal to 4n plus 3. Now, implies P minus 1 by 3 is odd. তাহলে কি হচ্ছে? এখানে বসিয়ে দাও P minus 1 by 2. और ना এখানে বসিয়ে দাও তাহলে n স্কয়ার তাহলে minus 1 into P minus 1 by 2 is congruent to this minus P 1. But this is odd, so this is minus 1. Implies P divides 2, but that is not possible. P is not prime, cannot divide. So this is a contradiction. So that means this is proof. Okay, this cannot be of this kind. Alright. So এইখানে কি করা যায়? How I'm quickly writing. I will not go more than that. This you try as an exercise. That there are infinitely many primes of the form. এই ট্রিকটা ইউজ করো, মনে করো P1, P2, PR. These are the only primes of the form 4n plus 1. Then take 2 and take square and take 1. Take a prime which divides this. This has to be 4n plus 1 time by this theorem, and that cannot be any of this. So there are infinite many primes of the form. And this is even only if also. That I could not go, otherwise I had to prove that P minus 1 factorial is from into minus 1. But then he will some congruence. So we will leave that. Okay, hope you get some interest in number theory.
তোমরা কেউ কিছু জিজ্ঞেস করবে স্যারকে? কোনো প্রশ্ন যদি মনে থাকে?
তোমরা প্রশ্ন করলে স্যার মনে হয় খুশি হবে।
So it is see, খুব তাড়াতাড়ি lecture তো see you need some sort of course to do some. Otherwise definition এই অনেক ওগুলো আস্তে 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 করা যায়, then you can understand. Yes.
স্যার বলছি আমরা এতক্ষণ ধরে এত কিছু শিখলাম, কিন্তু ইম্পর্টেন্সটা কি, এটা আমরা কোথায় ইউজ করব?
অনেক অনেক আসলে see that is hardly thought that number theory cannot be used, so it cannot be used in war, so he was very happy. But today number theory is used, you know, in coding theory, cryptography. Coding means what? Suppose some data is sent from somewhere to somewhere, then there will be disturbance in the channel, then you get something. Now what you have to do, you have to get back. Okay? So in a certain radius, if you by mistake you assume that cannot happen more than this radius, then you go to the center. Like that what? Suppose you are here and your colleague is somewhere. If you say 0, they will not send bomb. If you say 1, they will put a bomb. Now the mistake, 1, 0, 1 in a communication mistake happen, then what will happen? Totally ulta ho jayega. So what you will do? You will say 5, 0 is bomb. Don't bomb. 5, 1, bomb. Now the mistake can happen 1 or 2. If there are instead of 4, 0 and 1, 1, then that is one mistake is there, that means 5, 0. Assume. But this way, that also if you use number of zeros more, then you see expenditure will go up. Then the coding theory is such that you don't waste much, but you do in this trick, you do in some system that your mistake cannot be more than that, and you go to the radius. If it is here, you go to the radius, that is the center, that is the right one. So that way, so and then there are cryptography, your all the credit card, everything. But there is a beauty also. Number 3 has beauty.
স্যার 0 ফ্যাক্টোরিয়াল 1 I can.
But that is assumption, because it will see something you have to assume. Okay? Okay, why not? Don't you so data you understand? So you have to assume that so that it tallies.
ওই মাইকটা আরো খারাপ।
স্যার বলছি আমরা যখন করছিলাম মানে 5 সামথিং তখন করছিলাম, তখন n minus 1 মানে এই টপিকে 5 equal to 4, তাহলে যখন 5 of 4 equal to করছিলাম তখন 2 হয়েছে।
হ্যাঁ, এটা কোপ্রাইম যদি হয়, যে a আর b কোপ্রাইম হয়, মানে জিসিপি 1 হয়, তাহলে 5a into 5b is equal to 5a। কিন্তু পাওয়ারের ক্ষেত্রে সেটা হবে না, তার আলাদা ফর্মুলা আছে। আর 10 plus 2 and 5 are coprime, that is equal to 5 2 into 5m। কোপ্রাইম হলে হবে, ওই জন্য you do for prime power and then multiply. Because একটা যদি 2 square into 5 cube হয় তাহলে 5 of 2 square into 5 cube is 5 2 square into 5 5 cube. That you can easily do. Up to that, how many 5 divisors of 5 are there? So 5 to the power 5 4 minus 5 cube. I of that. I of 5 4, 5 to the power 4 is 5 cube minus 5 4 minus 5 cube.
স্যার বলছি ট্রায়াঙ্গুলার নাম্বার নিয়ে একটা প্রশ্ন ছিল।
But you read that book public.
হ্যাঁ
Public. There is a book. There are many interesting things. Okay. So there you write to me by email. I'll give the references.
আচ্ছা না মানে বই তো আছে, বইরই একটা প্রশ্ন তাই।
No, but that I have to see what is the exact thing. It is not that everything immediately. It also takes a couple of minutes for me to fix. No? I don't know what is the question. You write to email is there.
ঠিক আছে, আর কেউ কিছু বলবে না? So we thank sir for giving some very basic concepts and problems of a deep subject, number theory, in a very simple and easy way nicely. And sir, we hope that the students will get in touch with you through email. They will have many problems in their minds. They can definitely get in touch with you.
And usually, some questions you ask the local people, they will guide you. If there is something remains, you send to me. Okay? Then with some time, if you are traveling and all, I'll always answer. What is and give the reference. Sometimes you have to tell a lot of things to come to explain something. So then you can give reference because you have to read that. No? Because if I say that because of this happens, that is as good or as bad. Because that cannot be done in one. So I can give a reference. Otherwise, email I can, if you get stuck, I can.
So let us thank sir once again with a big round of applause.